In this demo, we're going to use what we've learned in this module to see if we can make our CalcEngine program a little bit easier to manage and maintain. Here we are inside of our CalcEngine program, and what I want to focus on is this math equation class. If we take a look at this class, it has a number of distinct responsibilities, some that are common to all operations, then some things that are specific to an individual operation. If we look here, first of all, it declares all the fields necessary to do the work. Then it has to have getters and setters for all those fields. Then it has the variety of constructors. And then if we scroll down here towards the bottom, we get to this execute method, which actually is doing a number of different things. And what I found is that when you see code like this, where you've got a big condition like this, and there's individual tasks inside of there, as a program gets more complex and you start to work inside this method, this is a place where very often enhancing or modifying the program will introduce errors. Because we've got a bunch of kind of loosely related code kind of clumped together. This is a great opportunity for us to use the class inheritance features of Java to have a better division of responsibilities. So what I want to do is go here, and I'm going to go ahead and add a new class. And we're going to call this class CalculateBase. So I'm just going to go ahead and new this guy up. And as I mentioned, we'll call this class CalculateBase. And based on its name, you can tell that it's probably going to be a base class, so other classes are going to inherit from it. That's not a requirement, it's just something I tend to do when I know a class is going to be used only as a base class. This class will actually act as a common point of inheritance from all of our separate operations. So the thing that's going to be common to all these operations is the series of fields we need to declare, right? Left val, right val, and result. In addition to that, we're going to have getters and setters for each of those fields. So that takes care of the fields. And now we need some constructors. Now we'll of course want our no argument constructor. So we'll just say public CalculateBase, and then give it an empty body. Let's go ahead and create our other constructor. We'll call this one, again, public CalculateBase. And in this one, we want to get our left val and our right val. And of course, inside of here, we're going to go ahead and set those into the fields. So now we have all of our value management, right? The ability to store the values we need, store the result, get and set those values and result, and then construct the instance of CalculateBase. The last thing we want to do is have this idea of performing an actual operation, right? We'll actually do a calculate. But the way we actually calculate will be different for each class that inherits from this. So what we're going to do is go ahead and create a void method called calculate. But because there's no single definition of calculate, we're going to go ahead and make this one abstract. And of course, as an abstract method, it has an empty body. And because there's an abstract method, we need to go ahead and make the class abstract as well. So that gives us our base class for all of our operations. Now let's go ahead and create a class that inherits from CalculateBase that does an individual operation. Let's start with adder. So again, we'll add a new class. We'll call it adder. So it will extend CalculateBase. So inside of here, we want to have the constructors that we need, right? So again, we'll have the no argument constructor. And then we'll have the constructor that accepts left and right values. And inside of here, we're just going to call up to our base class constructor that accepts those same values. So with that simple bit of code, we've now taken care of kind of linking this derived class to the base class and passing the values that we need into the base class. So now the last thing to do here is just go ahead and implement calculate for this implementation, right? So we'll call it, again, public void calculate. So we have our method there. Let's go ahead and put the override annotation on here. So now inside of here, we'll go ahead and implement the way an adder does its calculate. And all we're going to do is add the two values together. So we'll declare a local variable here. So now when we go to perform this operation, if I try to use left val and right val directly, it's not going to work because those are marked as private inside the base class. So what we can do though is go ahead and still use the getters, right? So we'll say get left val, and we'll add that to get right val. Now inside of here, we'll go ahead and store that in the result. So we'll simply call our set result and pass in value. And that's our complete adder implementation. And you see what we've done here is that the adder class is very focused on a very specific capability, adding values together. Right, if we go ahead and create a subtractor, it's going to be very much the same. So we'll go ahead and add that class in. Again, we'll call it subtractor. So subtractor will again extend CalculateBase. We'll have those same constructors we had before. We have the no argument constructor and then one to accept the left and right value. Again, we're going to go ahead and override calculate. Then inside of here, we're simply going to subtract one value from the other and store it back in result. And then we're going to do that same thing with a divider and a multiplier. So we now have the four operations. The adder we created earlier, subtractor, and if I look at divider, it looks just like the other classes except calculate does division, and multiplier. It looks just like the other classes except calculate does multiplication. So we now have our four classes that inherit from calculate base. Right, so let's go to our main method now, and let's go ahead and use these classes. So I'm going to scroll down here to the end. The first thing we'll do is just go ahead and print out a little message in the output window so we can see where the results of our new code starts. So we simply print out that message using inheritance. And then here we'll go ahead and do the work that we can do using our new classes. So remember that all of our classes inherit from calculate base. So let's go ahead and declare an array of type calculate base. So we have our array and its name is calculators. And let's go ahead and use the bracket style initialization syntax. So what we'll do inside of here is just new up each one of our classes. So first I'll new up a divider that accepts 150. Then put a comma. Now let's go ahead and new up an adder. And we'll go ahead and new up a subtractor and a multiplier as well. So now we have all four operations in here. I'm just going to go ahead and move this divider over so it lines up with the rest of them. So our calculate base can do all four operations. And we're using the same values here we've used earlier when we were using our math equation class. So now with that set up, what we can do is now loop through that array. Right, so let's go ahead and do a for loop. We'll declare a variable calculate base called calculator. It's going to loop through our calculators. And then inside of here, all we're going to do is for each calculator, call its calculate method, and then we'll print out the result for each one. And so now we have a new complete functionality using the four basic operations. Right, so if I go ahead and run this now, okay, our program completes. Let's just enlarge this output window a little bit so we can see. And we see we have our four results here. Dividing 100 by 50 gives us 2. Adding 25 and 92 again gives us 117. 225 minus 17 gives us 208. And multiplying 11 by 3 gives us 33. So everything works just as expected. And everything works just as it did before. But the key difference here is this idea of manageability and maintainability, right? Kind of a localization of responsibility. If I go into my math equation, again, this execute method is reasonably complex given the simple things that we're doing. And it's this kind of code that easily breaks when you're enhancing a program or changing the program. If we compare that execute method to the adder class's calculate, which is two very simple lines, you see that changing behaviors are going to be much simpler in this environment as a result of having used inheritance and then specialization in the derived classes.